Now this is the next phenomenon related with light that we are going to see in detail, interference of light. Actually, interference phenomena is observed for light waves as well as sound waves, for transverse waves as well as longitudinal waves, and it is based on the principle of superposition of waves. So we have seen already this principle in sound section, superposition of waves. So the name of the title of the chapter, superposition of waves, it is related with this phenomena. So the first point that we should know is the phenomenon of interference is observed in sound waves as well as the light waves. So example of interference in sound waves is like phenomenon of beat, and formation of stationary wave. In resonative experiment, we have used this phenomenon, and phenomenon of beat is used in so many cases, as well as light waves. So in case of light wave, it is called as like interference of light. Interference of light. So this part we have already seen in sound section. Now we are going to see this part, interference of light. So the phenomenon of interference for both waves, light wave as well as sound waves, is based on the principle of superposition of waves. So we have seen this principle in sound section. Again we will repeat it, and the explanation will be related with the light waves like this. So statement. Statement of the principle of superposition of waves. First we will give the statement in words, and then we will give it in mathematical form. Statement: when minimum two waves are required, two or more light waves cross each other or superimpose each other at a point, then each wave produces its own displacement. Each wave produces in its own displacement at that point, means at the point of crossing, at that point, independent of other waves. The other waves are direction, amplitude का है कि का इफेक्ट होती है independent of other waves. This is the first part of the principle, and the resultant displacement at the point of crossing, point of superimposition, at the point of crossing is given by vector sum of individual displacements due to each wave. So these are the two parts. When two or more light waves arrive at a point simultaneously or cross each other at a point, then each wave produces its own displacement at that point, and it is independent of the resultant displacement at the point of crossing is given by the vector sum. So we know the rules for vector addition. Now what is meant by own displacement, what is meant by vector sum, how the resultant displacement is calculated, that now we have to see. Now let us explain this. Explanation. If y1, y2, y3 yn are the displacements due to n waves arriving at a point, then resultant displacement y at that point is given by y is equal to y1 plus y2 plus y3 yn. So this is a mathematical statement of the principle of superposition of waves. This principle of superposition of waves is given mathematically like this. Y is equal to y1 plus y2 plus y3 plus y4. So we are taking the vector sum, means magnitude and direction both are important. Now we already know the different laws for vector addition. Law of parallelogram, it is the best law. but it can be used only for two vectors. If there are number of vectors, then we can use law of polygon like this. Now, in this case, we know the simple rules of vector addition. For example, if this is a body of mass m, this is a body of mass m. So when a force F1 is applied, say in this direction, then it produces the displacement S1. Now, same body is used if the force F2 is applied in the same direction. The displacement is S2, but S2 is less because F2 is less. So let S1 is equal to magnitude of S1 is equal to say 5 centimeter. Displacement due to force F1. Magnitude of S2 is less 4 centimeter is equal to displacement due to the force F2. Then, if S1 and S2 are in the same direction, then the resultant displacement is R and its magnitude is equal to 5 plus 4 is equal to 9 centimeter. So R is equal to magnitude of R is equal to S1 plus S2 for same direction. Vector R as magnitude equal to S1 minus S2 mod, that is equal to 5 minus 4, that is equal to 1 centimeter for opposite direction of S1 and S2. So we know this simple rule. Same direction, add their magnitude to find the resultant magnitude, and opposite direction, subtract their magnitude like this. So same direction, add their magnitude, opposite direction, subtract their magnitude. These are the simple rules if the two forces are parallel or anti-parallel. So this type of simple rules of vector addition are used to explain the phenomena of interference of light. Now, first we will consider this interference of water waves. Why we are using ripples? Because ripples are transverse waves and light waves are also transverse waves. So the nature of the interference pattern for light waves will be same as the interference produced by the water waves, and therefore we will use the simple case of ripples. So that vector addition can be explained by using the example of the ripples like this. So for vector addition, we are using this simple example. Suppose this is a steady surface of water. Steady surface of water, and at point A, a stone is dropped. So ripples are produced. Suppose the wave produced from point A is like this. So its amplitude is A1. This wave will move in this direction. Now, At point B, one more stone is dropped, but it is lighter in weight than the stone dropped at point A. So again, the ripples are produced, but it will have smaller amplitude A2. Let A1 is equal to amplitude of the first wave 5 cm, A2 is equal to amplitude of the second wave 4 cm. So wave number 1 and wave number 2, they are traveling on the water surface in opposite direction. So they will cross, they will superimpose, say at point P. So at point P, when the two waves arrive, what is the resultant displacement? So R is equal to resultant displacement at the point of superposition, point of crossing, point of superposition P, resultant displacement at the point of superposition P. So R depends on A1, A2 and phases of two waves at the point of crossing P. Point of crossing P. So this factor is very important. So we know the meaning of phase. Phase is a physical quantity which gives the idea of magnitude and direction. So we already know phase of a wave phi gives magnitude and direction of the displacements. For example, if I consider one wave, then this is 0 degree, this is 90 degree, this is 180 degree, this is 270 degree, and this is 360 degree. So this is the position of crust. This is the position of trough. So for position of crust C, for position of crust C, phase angle, phase is taken as 90 degree, direction of displacement is upward, direction of displacement is upward, and magnitude equal to amplitude A. This is the amplitude. Now this, for the position of trough T, for the position of trough T. Now if we draw perpendicular, this angle is 270 degree. For the position of trough T, phase equal to, the phase angle is taken as 270 degree, and the direction of the displacement is downward and magnitude of displacement. So this is the general rule of this displacement. Magnitude of the displacement is equal to amplitude of the wave equal to A. So this distance is also A. For a wave, the amplitude remains the constant. So we are using this convention for a wave for the position of thrust. The phase angle is taken as 90 degree, and for the trough, the phase angle is taken as 270 degree. Crust, the displacement is in the upward direction, having magnitude is equal to amplitude like this. So we will consider 4 simple cases of crossing of the two waves. Case number 1. Suppose crust of the first wave having amplitude A1 and crust of the another wave having amplitude A2, they cross, they superimpose each other at this point. Then the two displacements are in the upward direction. For the first wave, the displacement is A1 in the upward direction, A2 in the upward direction. So same direction at their magnitude. So in this case, the resultant displacement at the point of crossing will be equal to A1 plus A2, like this. So the resultant displacement R is equal to A1 plus A2 in the upward direction. Second case, suppose trough of the first wave having amplitude A1, trough of the second wave having amplitude A2. Then in this case, again same direction at their magnitude by this rule. The resultant displacement R is equal to A1 plus A2. Both the displacements at the point of crossing are in the downward direction. Due to the first wave 5 cm, due to the second wave 4 cm, so 5 plus 4 is equal to 9. So in this case, the resultant displacement at the point of crossing is equal to 9 cm in the upward direction. In this case, the resultant displacement is again 9 cm, but in the downward direction. So these are the two cases. Now, case number 3. Suppose crust of the first wave having amplitude A1 and trough of the second wave having amplitude A2. Now if these two waves superimpose each other at point P, at the point of crossing P, then in this case one displacement at the point of crossing is A1 is equal to 5 cm in the upward direction, second displacement due to the second wave is A2 is equal to 4 cm in the downward direction. So the two displacements are in opposite direction, subtract their magnitude. So in this case, R is equal to A1 plus A2 and it is in the direction of the larger vector. So this is R. So R is equal to A1 minus A2. One more case. Case number 4. Suppose trough of the first wave having amplitude A1 5 cm and crust of the second wave If the two waves superimpose each other, then in this case again the two displacements are in opposite direction. Therefore, R is again A1 minus A2, but it is in the direction of larger vector, that is in the downward direction. So A1 is 5 centimeter more, like this. So now if you see these four cases, then one more special case. Case number 5. When crust of the first wave having amplitude A and trough of the second wave having amplitude E. So A1 is equal to A2 is equal to E. Then in this case R is equal to 0. No displacement at the point of crossing. R is equal to 0. No displacement. No displacement at the point of crossing. म्हणजे असं पण होऊ शकतं, जरी दोन वेव क्रॉस झाले तरी ग्रीन जंक्शन डिस्प्लेसमेंट 0 पण येऊ शकते. ॲक्च्युली ह्या केसेस खूप महत्त्वाच्या आहेत, आपल्या बोर्डच्या बुक्समध्ये काही दिलेलं नाही त्या लक्षात. So to understand the phenomena of interference, these figures are very important. We will use them throughout. R is equal to A1 plus A2 means there is a addition. Addition of displacements A1 plus A2, and in these cases subtraction of displacements A1 minus A2, like this. So when the ripples, when the water waves from the two point A and B cross each other on the water surface, then either there is a addition or subtraction of the displacement due to the waves. So this phenomena of addition and subtraction is called as interference. The interference phenomenon is meaning high. When two or more waves arrive at a point simultaneously, then either they will add or subtract. So this phenomena of addition and subtraction is called as interference. Now why addition in case number 1 and 2? Because the two waves are in the same phase. Crust means 90 degree. Trough means 270 degree. So two waves cross in same phase. Crust or trough means same phase. In this case, two waves cross in opposite phase. Same phase crossing for two cases. Opposite phase crossing. Opposite phase means phase difference is 180 degree. Like this. So we already know the meaning of same phase and out of phase. The crusters are in the same phase, trough are in the same phase, crust and trough are in the opposite phase. So phase difference is 180 degree in the second case. So phase difference is equal to phase difference is equal to 180 degree. Phase difference is 0. Like this. So in the first two cases there is the addition because the two waves cross each other in the same phase. So it is called as the constructive interference. And remaining case number 3 and 4 gives the destructive interference. So now you can define. So first two cases use constructive interference. and here we get the destructive interference. Destructive interference. So there are two types of interference: constructive interference and destructive interference, like this. So before going to see the details point of differences between constructive and destructive interference, first let us define the phenomena of interference of light. Definition of interference of light. Definition number 1. Now, in the first two cases, the resultant amplitude is maximum, therefore intensity is also maximum. So there is a variation in the intensity of light. Variation in the resultant amplitude. So distribution of intensity will be non-uniform, larger at some point and smaller at. So the phenomena of variation in the intensity of light. The first definition is like this. The phenomenon of variation in intensity of light. Intensity is directly proportional to the square of the amplitude. The phenomenon of variation in the intensity of light due to superposition of light waves. Due to superposition of light waves is called interference. Interference of light. So maximum distortion, minimum distortion, maximum, minimum, like this. We get alternate points of maximum and minimum displacement like this. Second definition. So addition or subtraction. When the water waves or light waves, when the transverse waves cross each other at different points, then either there is an addition or subtraction. So that addition of displacement so second definition I have written like this. So in the first two cases there is the addition of distortion. Addition is also called as the enhancement. In physics we call it as, in mathematics it is also called as the enhancement. So this is another name for addition. And subtraction means cancellation. So cancellation may be partially or may be completely. In this case there is a complete cancellation of the two displacement because they are equal in amplitude. A1 is equal to A2 is equal to A. So in this case there is no resultant displacement. Here there is some resultant displacement either in the up or down direction like this. So addition means enhancement and subtraction means cancellation. So when the ripples or transverse waves cross each other like this, either there is a addition in the first two cases or there is a subtraction, cancellation in the remaining cases. So this phenomena of enhancement or cancellation of the displacement at the point due to the superimposition of light waves is called as the interference. आता interference types पण आपल्याला माहिती आहे. Whenever there is a addition, enhancement, then it is called as a constructive interference. And when there is a subtraction, cancellation of the dispersion, then it is called as a destructive interference. So now we know the definition of interference. Now we have to see the types of interference. So there are two types of interference. One is a constructive interference and other is a destructive interference. And their distinguishing factors are given like this. So that table showing the point of differences between constructive and destructive interference is not given in our notes, in our book. So you have to add this. So there are two types of interference, constructive and destructive interference. In this figure, we have shown these two types. In figure case number 1 and 2, there is a constructive interference, and case number 3 and 4, there is a destructive interference. So for constructive interference, there is the addition of displacement, but for that purpose, the two waves cross in the same phase, and here for destructive interference, the two waves cross each other in the opposite phase. So this phase factor is important for the phenomena of interference of light like this. So the first quantity is related with the phase. So the first quantity is like this. For constructive interference, two light waves arrive at a point simultaneously, means they cross each other simultaneously in same phase. Now on this side, for destructive interference, the two waves arrive at a point simultaneously in opposite phase. So in the same phase, in opposite phase. Second point, displacements of two waves add to each other on this side. Second point, the displacement of the two waves cancel each other, cancel or subtract each other. Third, therefore, resultant displacement at the point of crossing is maximum. Resultant displacement is maximum on this side. Third, resultant displacement at the point of crossing is minimum or zero. Is minimum or it also be zero, special case. like this. Now, for light wave or for any wave, intensity is directly proportional to the square of the amplitude. Therefore, the fourth point. The amplitude of resultant light wave of the resultant light wave at the point of crossing is maximum. R is equal to E1 plus E2. The resultant amplitude is maximum on this side. The resultant amplitude of the resultant wave at the point of crossing is minimum or maybe 0. Is minimum. Therefore, intensity of light at the point of superimposition is maximum, because intensity is directly proportional to square of amplitude. On this side, intensity is minimum. Intensity of light at the point of crossing is minimum. There, at the minimum and maximum intensity are many kinds of phenomenon. For example, now at this point there is maximum intensity from the tube light. Now, if the object is held like this, then there is a less intensity. It is called as a darkness. So, maximum intensity means the point of crossing will appear bright, more brightness, and intensity is minimum, maybe 0. It is called as a darkness or dark. So, point of crossing appears bright, point of crossing appears darker. So, the last point of difference is this. The point of crossing looks or appears or looks bright. The point of crossing appears dark. Looks bright, looks dark. Bright band, dark band. Darkness is observed, brightness is observed. So same question is also asked like this. Explain the origin of brightness and darkness in an interference of light. हेच एक्सप्लेनेशन द्यायचं असतं, फक्त तिथे पॅराग्राफच्या फॉर्ममध्ये आपल्याला आन्सर द्यायचं असतं ते लक्षात. सो देर आर two more point of differences, but we will see it afterward. Point number 7 is for phase difference. Phase difference is equal to, and point number 8 is equal to path difference. हे 7 आणि 8 नंबरचे पॉइंट आपण नंतर बघणार आहोत. So distinguish between the constructive and destructive interference is given like this. So if the question is asked, explain the types of interference, then you have to give these two types. So first we will complete the paragraph of constructive interference, and it can be given like this. For constructive interference, the two light waves arrive at a point simultaneously in the same phase. Therefore, their displacement added to each other. Hence, the resultant displacement at the point of crossing becomes maximum, and therefore the amplitude of the resultant wave at the point of crossing is maximum. Since intensity is directly proportional to the square of amplitude, therefore intensity at the point of superposition is also maximum, and intensity maximum, therefore the point appears brighter. This is called constructive interference. दिस इज कॉल्ड डिस्ट्रक्टिव्ह इंटरफरन्स. तर याप्रमाणे आपल्याला हे ब्राईटनेस आणि डार्कनेसचे ओरिजिन एक्सप्लेन करता येऊ शकतात. ब्राईटनेस मीन्स कन्स्ट्रक्टिव्ह इंटरफरन्स अँड डार्कनेस मीन्स डिस्ट्रक्टिव्ह इंटरफरन्स लाईक दिस. दीज आर कॉल्ड एज ए ब्राईट बँड अँड डार्क बँड. जसं आपल्याला स्टेशनरी वेव्हमध्ये अँटी नोड्स आणि नोड्स मिळतात. सो अँटी नोड करस्पॉन्ड टू ब्राईट बँड अँड नोड्स करस्पॉन्ड टू द डार्क बँड. किंवा बीट फेनॉमेनामध्ये आपल्याला वॅक्सिंग ऐकू येतो. वॅक्सिंग मीन्स मॅक्झिमम इंटेन्सिटी ऑफ साऊंड. म्हणजे इथले ब्राईट बँड म्हणजे वॅक्सिंग म्हणजे अँटी नोड, आणि इथले डार्क बँड म्हणजे वॅनिंग म्हणजे नोड. तर ह्या तिघे फेनॉमेना पॅरलल आहे, फक्त तिघांचं ओरिजिन वेगळं आहे. तर मागे आपण सुपरपोजिशन ऑफ वेव्हजमध्ये एक टेबल तयार केलं होतं. फेनॉमेना ऑफ इंटरफरन्स डिपेंड अपॉन द फेज डिफरन्स. Phenomena of it depend upon the slight difference in the frequency, and phenomena of superposition formation of stationary wave depends upon the opposite direction. So necessary condition we already know for these three phenomena like this. Okay, we will stop here. Then next time we will see the nature of the interference pattern.